Chapter 16. Semiconductor Devices. Exercises pages 363 to 364. Exercises Q1.1 page 363. Choose the correct option. In a BJT, the largest current flow occurs 1. In the emitter 2. In the collector 3. In the base 4. Through CB junction. Solution. In the emitter. Exercises Q1.2 page 363. Choose the correct option. A series resistance is connected in the Zener diode circuit to 1. Properly reverse bias the Zener 2. Protect the Zener 3. Properly forward bias the Zener 4. Protect the load resistance. Solution. Properly reverse bias the Zener. Exercises Q1.3 page 363. Choose the correct option. A LED emits visible light when its 1. Junction is reverse biased 2. Depletion region widens 3. Holes and electrons recombine 4. Junction becomes hot solution. Holes and electrons recombine. Exercises Q1.4 page 363. Choose the correct option. Solar cell operates on the principle of 1. Diffusion 2. Recombination 3. Photovoltaic action 4. Carrier flow. Solution. Photovoltaic action. Exercises Q1.5 page 363. Choose the correct option. A logic gate is an electronic circuit which 1. Makes logical decisions 2. Allows electron flow only in one direction 3. Works using binary algebra 4. Alternates between 0 and 1 value. Solution. Makes logical decisions. Exercises Q2.1 page 363. Answer in brief. Why is the base of a transistor made thin and is lightly doped? Solution. The base of a transistor is lightly doped than the emitter and is made narrow so that virtually all the electrons injected from the emitter in an NPN transistor diffuse right across the base to the collector junction without recombining with holes. That is, the base width is kept less than the recombination distance. Also, the emitter is much heavily doped than the base to improve emitter efficiency and common base current gain alpha. Exercises Q2.2 page 364. Answer in brief. How is a Zener diode different than an ordinary diode? Solution. A Zener diode is heavily doped. The doping concentrations for both P and N regions is greater than 1018 cm3 while those of an ordinary diode are about 1017 cm3 or less. Due to this, the peak inverse voltage PIV of an ordinary diode is higher than a Zener diode and the breakdown occurs by impact ionization avalanche process. Their LV characteristics are otherwise similar. Exercises Q2.3 page 364. Answer in brief. On which factors does the wavelength of light emitted by a LED depend? Solution. The intensity of the emitted light is directly proportional to the recombination rate and hence to the diode forward current. The color of the light emitted by an LED depends on the compound semiconductor material used and its composition and doping levels. As given below. Typical semiconductor materials and emitted colors of LEDs. Material. Emitted colors. Gallium arsenide gauze, indium gallium arsenide phosphide, in GaAsP. Infrared. Aluminum gallium arsenide, alga as. Deep red, also IR laser. Indium gallium phosphide, in GaP. Red. Gallium arsenide phosphide, GaAsP, aluminum indium gallium phosphide, AlGaP. Orange, red or yellow. Gallium phosphide, GaP. Green or yellow. Aluminium gallium phosphide, AIGaP, zinc selenide, ZNSE, zinc selenide telluride, zincate nitrogen impregnated gallium phosphide, GaP. N. Green. Indium gallium nitride, InGaN gallium nitride, GaN, sine sulfide, ZNS. Blue and violet longer wavelengths green and yellow, are obtained by increasing the indium in content. Phosphor encapsulation produces white light. Aluminium gallium nitride, AlGaN. Ultraviolet. Exercises Q2.4, page 364. Answer in brief. Why should a photodiode be operated in reverse biased mode? Solution. A photodiode is operated in a reverse biased mode because as a photodetector or photosensor, it must conduct only when radiation is incident on it. In the reverse biased mode, the dark current for zero illumination is negligibly small, of the order of few picoamperes to nanoamperes. But when illuminated, the photocurrent is several orders of magnitude greater. Exercises Q2.5, page 364. Answer in brief. State the principle of solar cells. Solution. A solar cell is an unbiased p-n junction that converts the energy of sunlight directly into electricity with a high conversion efficiency. Principle. A solar cell works on the photovoltaic effect in which an EMF is produced between the two layers of a p-n junction as a result of irradiation. Exercises Q2.6, page 364. Answer in brief. State the uses of the solar cell. Solution. Uses of solar cells. 1. A solar cell array consisting of a set of solar cells is used during daylight hours to power electrical equipment as well as to recharge batteries, which can then be used during the night. 2. Solar cell arrays provide electrical power to equipment on a satellite as well as at remote places on the Earth where electric power lines are absent. 3. Large-scale solar power generation systems linked with the commercial power grid. 4. Independent power supply systems for radar detectors, monitoring systems, radio relay stations, road lights, and road signs. 5. Indoor uses include consumer products like calculators, clocks, digital thermometers, etc. They use very low levels of power and work under low brightness long-wavelength light from incandescent lamps, etc. Exercises Q3, page 364. Draw the circuit diagram of a half-wave rectifier. Explain its working. What is the frequency of ripple in its output? Solution. A device or a circuit which rectifies only one half of each cycle of an alternating voltage is called a half-wave rectifier. Electric circuit. The alternating voltage to be rectified is applied across the primary coil P1 P2 of a transformer. The secondary coil S12 of the transformer is connected in series with the junction diode and a load resistance RL, as shown in the following figure. The alternating voltage across the secondary coil is the AC input voltage V. The D voltage across the load resistance is called the output voltage V0. Half-wave rectifier circuit. Working. Due to the alternating voltage V, the pregin of the diode becomes alternatively positive and negative with respect to the N region. During the half cycle when the pregin is positive, the diode is forward biased and conducts. A current IL passes through the load resistance RL in the direction shown. Voltage waveforms for a half-wave rectifier, A input, B output. During the next half cycle, when the pregin is negative, the diode is reverse biased and the forward current drops to zero. Thus, the diode conducts only during one half of the input cycle and thus acts as a half-wave rectifier. The intermittent output voltage V0 has a fixed polarity but changes periodically with time between 0 and a maximum value. IL is unidirectional. The above figure shows the input and output voltage waveforms. The pulsating to output voltage of a half-wave rectifier has the same frequency as the input. Exercises Q4, page 364. Why do we need filters in a power supply? Solution. A rectifier half-wave or full-wave outputs a pulsating to which is not directly usable in most electronic circuits. These circuits require something closer to pure D as produced by batteries. Unlike the pure D waveform of a battery, a rectifier output has an AC ripple riding on a D waveform. The circuit used in a D power supply to remove the ripple is called a filter. A filter circuit can produce a very smooth waveform that approximates the waveform produced by a battery. The most common technique used for filtering is a capacitor connected across the output of a rectifier. Exercises Q5, page 364. Draw a neat diagram of a full-wave rectifier and explain its working. Solution. A device or a circuit which rectifies both halves of each cycle of an alternating voltage is called a full-wave rectifier. Electric circuit. The alternating voltage to be rectified is applied across the primary coil P1-P2 of a transformer with a center tapped secondary coil S12. The terminals S1 and S2 of the secondary are connected to the two pregens of two junction diodes D1 and D2, respectively. The center tapped is connected to the ground. The load resistance RL is connected across the common N regions and the ground. Full-wave rectifier circuit. Working. During the 1/2 cycle of the input, terminal S1 of the secondary is positive while S2 is negative with respect to the ground, the center tap T. During this half cycle, diode D1 is forward biased and conducts, while diode D2 is reverse biased and does not conduct. The direction of current I through RL is in the sense shown. Voltage waveforms for a full-wave rectifier: A input, B output. During the next half cycle of the input voltage, S2 becomes positive while S is negative with respect to T. Diode D2 now conducts, sending a current I through RL in the same sense as before. D1 now does not conduct. Thus, the current through RL flows in the same direction, i.e., it is unidirectional, for both halves are the full wave of the input. This is called full-wave rectification. The output voltage has a fixed polarity but varies periodically with the time between 0 and a maximum value. The above figure shows the input and output voltage waveforms. The pulsating to output voltage of a full-wave rectifier has twice the frequency of the input. Exercises Q6 page 364 explain how a Zener diode maintains a constant voltage across a load. Solution. Principle. In the breakdown region of a Zener diode, for widely changing Zener current, the voltage across the Zener diode remains almost constant. Zener diode is a voltage regulator. Electric circuit. The circuit for regulating or stabilizing the voltage across a load resistance RL against change in load current and supply voltage is shown in the above figure. The Zener diode is connected parallel to load RL such that the current through the Zener diode is from the N to P region. The series resistance Rs limits the current through the diode below the maximum rated value. From the circuit, I equals is plus IL. And V equals I Rs plus VZ. Equals is plus IL Rs plus VZ. Working. When the input and regulated to voltage V across the Zener diode is greater than the Zener voltage VZ in magnitude, the diode works in the Zener breakdown region. The voltage across the diode and load RL is then VZ. The corresponding current in the diode is LZ. As the load current I, or supply voltage V, changes, the diode current is adjusts itself at constant VZ. The excess voltage VVZ appears across the series resistance for constant supply voltage. The supply current I and the voltage drop across RS remain constant. LF. The diode is within its regulating range. An increase in load current is accompanied by a decrease in is at constant VZ. Since the voltage across RL remains constant at VZ, the Zener diode acts as a voltage stabilizer or voltage regulator. Exercises Q7 page 364. Explain the forward and the reverse characteristic of a Zener diode. Solution. The forward bias region of a Zener diode is identical to that of a regular diode. There is a forward current only after the barrier potential of the PN junction is overcome. Beyond this threshold or Q10 voltage, there is an exponential upward swing. The typical forward voltage at room temperature with a current of around 1 mA is around 0.6 V. In the reverse bias condition, the Zener diode is an open circuit and only a small reverse saturation current flows as shown with a change of scale. At the reverse breakdown voltage, there is an abrupt rapid increase in the current. The knee is very sharp, followed by an almost vertical increase in current. The voltage across the Zener diode in the breakdown region is very nearly constant with only a small increase in voltage with increasing current. There is a minimum Zener current, is min, that places the operating point in the desired breakdown region. At some high current level, IZM, the power dissipation of the diode becomes excessive, beyond which the diode can be damaged. Zener diode characteristics. The IV characteristics of a Zener diode is not totally vertical in the breakdown region. This means that for slight changes in current, there will be a small change in the voltage across the diode. The voltage change for a given change in current is the resistance RZ of the Zener diode. Exercises Q8, page 364 explain the working of a LED. Solution. Working. An LED is forward biased with about 1.2 V to 3.6 V at 12 mA to 20 mA. Majority carriers electrons from N-type layer and holes from the P-type layer are injected into the active layer. Electrons cross the junction into the player. In the active player, some of these excess minority carriers, electrons, recombine radiatively with majority carriers, holes, thereby emitting photons. The resulting photon has energy approximately equal to the bandgap of the active layer material. Modifying the bandgap of the active layer creates photons of different energies. Working of an LED. In the energy band diagram, this recombination is equivalent to a transition of the electron from a higher energy state in the conduction band to a lower energy state in the valence band. The energy difference is emitted as a photon of energy HV. Exercises Q9, page 364 explain the construction and working of the solar cell. Solution. Construction. A simple p-n junction solar cell consists of a p-type semiconductor substrate backed with a metal electrode back contact. A thin N layer, less than 2.5 micrometers, for silicon, is grown over the p-type substrate by doping with suitable donor impurity. Metal finger electrodes are prepared on top of the N layer so that there is enough space between the fingers for sunlight to reach the N layer and, subsequently, the underlying p-n junction. Sectional view of a solar cell. Working. When exposed to sunlight, the absorption of incident radiation, in the range near UV to infrared, creates electron hole pairs in and near the depletion layer. Consider light of frequency versus incident on the p-n junction such that the incident photon energy HV is greater than the band gap energy e.g. of the semiconductor. The photons excite electrons from the valence band to the conduction band, leaving vacancies or holes in the valence band, thus generating electron hole pairs. The photogenerated electrons and holes move towards the N side and P side, respectively. If no external load is connected, these photogenerated charges get collected at the two sides of the junction and give rise to a forward photovoltage. In a closed circuit, a current I passes through the external load as long as the solar cell is exposed to sunlight. A solar cell module consists of several solar cells connected in series for higher voltage output. For outdoor use with higher power output, these modules are connected in different series and parallel combinations to form a solar cell array. Exercises Q10, page 364 explain the principle of operation of a photodiode. Solution. Construction. A photodiode consists of an N-type silicon substrate with a metal electrode back contact. A thin P-type layer is grown over the N-type substrate by diffusing a suitable acceptor dopant. The area of the player defines the photodiode active area. An ohmic contact pad is deposited on the active area. The rest of the active area is left open with a protective antireflective coating of silicon nitride to minimize the loss of photons. The non-active area is covered with an insulating opaque CO2 coating. Depending on the required spectral sensitivity, i.e., the operating wavelength range, typical photodiode materials are silicon, germanium, indium gallium arsenide phosphide, in Ga as P, and indium gallium arsenide, in Ga as, of which silicon is the cheapest while the last two are expensive. Working. The band gap energy of silicon is Eg equals 1.12 electron volts at room temperature. Thus, photons are particles with energies greater than or equal to 1.12 electron volts, which corresponds to lambda is less than or equal to 10 nanometers, can transfer electrons from the valence band into the conduction band. A photodiode is operated in the reverse bias mode, which results in a wider depletion region. When operated in the dark, zero illumination, there is a reverse saturation current due solely to the thermally generated minority charge carriers. This is called the dark current. Depending on the minority carrier concentrations, the dark current in an NC photodiode may range from 5 picoamperes to 10 nanoamperes. When exposed to radiation of energy HV is greater than or equal to Eg, in the range near UV to near IR, electron-hole pairs are created in the depletion region. The electric field in the depletion layer accelerates these photogenerated electrons and holes towards the N side and P side, respectively, constituting a photocurrent I in the external circuit from the P side to the N side. Due to the photogeneration, more charge carriers are available for conduction and the reverse current is increased. The photocurrent is directly proportional to the intensity of the incident light. It is independent of the reverse bias voltage. 1. Silicon, C, low dark current, high speed, good sensitivity between operator 400 nanometers and 1000 nanometers, best around 800 nanometers minus 900 nanometers. 2. Germanium, J, high dark current, slow speed, good sensitivity between operator 900 nanometers and 1600 nanometers, best around 1400 nm 1500 nm. 3. Indium gallium arsenide phosphide, in GaAsP, expensive, low dark current, high speed, good sensitivity between operator 1000 nanometers and 1350 nanometers, best around 1100 run 1300 nm. 4. Indium gallium arsenide, in Gauss, expensive, low dark current, high speed, good sensitivity between operator 900 nanometers and 1700 nanometers, best around 1300 nm 1600 nm. Exercises Q11.1, page 364. What is a logic gate? Solution. A logic gate is a basic switching circuit used in digital circuits that determines when an input pulse can pass through to the output. It generates a single output from one or more inputs. Exercises Q11.2, page 364. What do you mean by a truth table? Solution. Boolean expression. An equation expressing a logical compound statement in Boolean algebra is called a Boolean expression. A Boolean expression for a logic gate expresses the relation between inputs and output of a logic gate. Exercises Q11.3, page 364. What do you mean by a Boolean expression? Solution. The table which shows the truth values of a Boolean expression for a logic gate for all possible combinations of its inputs is called the truth table of the logic gate. The truth table contains one row for each input combination. Since a logical variable can assume only two possible values, 0 and L, there are two n combinations of n inputs so that the table has two n rows. Exercises Q12.1, page 364. What is a logic gate? Solution. A logic gate is a basic switching circuit used in digital circuits that determines when an input pulse can pass through to the output. It generates a single output from one or more inputs. Exercises Q12.2, page 364. Write the truth table and Boolean expression for an AND gate. Solution. The AND gate. It is a circuit with two or more inputs and one output in which the output signal is high if and only if all the inputs are high simultaneously. The AND operation represents a logical multiplication. The following figure shows the two input and gate logic symbol and the Boolean expression and the truth table for the AND function. Logic symbol. Boolean expression. Y equals A asterisk B. Truth table. Inputs. Output YA. B0. 0. 01. 0. 0010111. Exercises Q13.1, page 364. What are the uses of logic gates? Solution. Explanation. Uses. Any digital computation process consists of performing a sequence of arithmetical operations on the data of the problem. At each stage in the computation, the nature of the operation to be performed is decided partly by the predetermined program and partly by the outcome of earlier stages in the process. We therefore need switches with multiple inputs to perform logical operations, i.e., the outputs of these switches are determined in specified ways by the conditioned binary state of their inputs. These arrangements are known as logic gates, and mostly they are an extension of a simple transistor switch. Exercises Q13.2, page 364. Why is a NOT gate known as an inverter? Solution. The NOT gate or inverter. It is a circuit with one input whose output is high if the input is low and vice versa. The NOT operation outputs an inverted version of the input. Hence, a NOT gate is also known as an inverter. The small invert bubble on the output side of the inverter logic symbol, the following figure, and the over bar in the Boolean expression represent the invert function. Logic symbol. Boolean expression. Y equals A. Truth table. Input A. Output Y0. 1 1 0. Exercises Q14.1, page 364. Write the Boolean expressions for an OR gate. Solution. It is a circuit with two or more inputs and one output in which the output signal is high if any one or more of the inputs is high. The OR operation represents a logical addition. The figure shows the two-input or Gale logic symbol, and the Boolean expression, and the truth table for their function. Logic symbol. Boolean expression. Y equals A plus B. Truth table. Inputs. Output YA. B0. 0. 01. 0. 10. 1. 11. 1. 1. Exercises Q14.2, page 364. Write the truth table and Boolean expression for an AND gate. Solution. The AND gate. It is a circuit with two or more inputs and one output in which the output signal is high if and only if all the inputs are high simultaneously. The AND operation represents a logical multiplication. The following figure shows the two-input and gate logic symbol and the Boolean expression and the truth table for the AND function. Logic symbol. Boolean expression. Y equals A asterisk B. Truth table. Inputs. Output YA. B0. 0. 01. 0. 00. 1. 01. 1. 1. Exercises Q14.3, page 364. Write the Boolean expressions for a NAND gate. Solution. It is a circuit with two or more inputs and one output, whose output is high if any one or more of the inputs is low. The output is low if all the inputs are high. Logic symbol. Boolean expression. Y equals A dot operator B. Truth table. Inputs. Output YA. B0. 0. 11. 0. 10. 1. 11. 1. 0. The NAND gate is a combination of an AND gate followed by a NOT gate so that the truth table of the nano function is obtained by inverting the outputs of the AND gate. Exercises Q15, page 364. Why are the emitter, the base, and the collector of a BJT doped differently? Solution. A BJT being a bipolar device, both electrons and holes participate in the conduction process. Under the forward-biased condition, the majority carriers injected from the emitter into the base constitute the largest current component in a BJT. For these carriers to diffuse across the base region with negligible recombination and reach the collector junction, these must overwhelm the majority carriers of the opposite charge in the base. The total emitter current has two components, that due to majority carriers in the emitter and that due to minority carriers diffused from the base into the emitter. The ratio of the current component due to the injected majority carriers from the emitter to the total emitter current is a measure of the emitter efficiency. To improve the emitter efficiency and the common base current gain, it can be shown that the emitter should be much heavily doped than the base. Also, the base width is a function of the base collector voltage. A low doping level of the collector increases the size of the depletion region. This increases the maximum collector base voltage and reduces the base width. Further, the large depletion region at the collector base junction extending mainly into the collector corresponds to a smaller electric field and avoids avalanche breakdown of the reverse-biased collector base junction. Note: effective dopant concentrations of a NPN transistor, BPNP transistor are shown below. The base doping is less than the emitter doping but greater than the collector doping. Exercises Q16, page 364. Which method of biasing is used for operating a transistor as an amplifier? Solution: for use as an amplifier, the transistor should be in active mode. Therefore, the emitter base junction is forward biased and the collector base junction is reverse biased. Also, an amplifier uses an emitter bias rather than a base bias. Exercises Q17, page 364. Define alpha and beta. Derive the relation between them. Solution: the common base current ratio or current gain, alpha DC, is defined as the ratio of the collector current to emitter current. The common emitter current ratio or current gain, beta DC, is defined as the ratio of the collector current to base current. Exercises Q18, page 364. The common base DC current gain of a transistor is 0.967. If the emitter current is 10 mA, what is the value of base current? Solution: given current gain alpha equals 0.967, emitter current equals 10 mA. To find the value of base current of the transistor equals. Solution: exercises Q19, page 364. In a common base connection, a certain transistor has an emitter current of 10 mA and a collector current of 9.8 mA. Calculate the value of the base current. Solution: data: IE equals 10 mA, LC equals 9.8 mA. IE equals IB plus IC. Therefore, the base current IB equals IE plus IC equals 10 to 9.8 equals 0.2 mA. Exercises Q20, page 364. In a common base connection, the emitter current is 6.28 mA and the collector current is 6.20 mA. Determine the common base DC current gain. Solution: